So, today's lesson is on inverse trig functions. Now, what you forgot but were taught before about inverse is the x and y have been switched, or the domain and range have been switched for there to be an inverse. Now, for there to be an inverse, it has to pass what's called the horizontal line test, which means that if you draw a horizontal line, it can only hit the graph at one point. Now, sine and cosine have a problem. And you know the problem is, in fact, they all have problems, but sine and cosine you can visualize. What's the problem with the horizontal line test? Is that a wave, it fails every time. But what we can do is we can have a restriction, and on that restriction, it passes the horizontal line test, and therefore we have an inverse. So, that's a big preamble. We're going to visualize it, and we're going to practice it. Today, we're going to get back to remembering the unit circle and being that trig machine that we are, okay? And I know that you've forgotten, because that's my job to help you remember and keep practicing. So, we're going to start here. We're going to start with the graph of just sine. Sine starts in the middle. At pi over 2, sine is at positive 1. And if I continued the wave, and it's off my graph, at pi would be in the middle, then down, and then up again. But for this graph, I only see this part of it. Now, if I go to the negative angle, like to the left, and understand the pattern, at negative pi over 2, it's at the bottom of the wave. And if you like, the middle of the wave would be off my graph right there. So when I see the wave, this is what sine looks like. Sine starts in the middle and then goes to the maximum. And then middle, bottom, middle, top, and follows that pattern. And if I follow that pattern to the left, it then goes to the bottom of the wave to the left and continues. Now, what we're going to do is, the points that you obviously see here that we're going to inverse, do you see 3 of them right there? So the first point to inverse is super easy. Well, the first point is 0, 0. Well, what happens when I inverse 0, 0? X and y? It's exactly the same, so it stays at 0, 0. But the next one, the angle is pi over 2, and the answer is 1. So if I inverse that, now my x value is 1, and my answer is pi over 2. So at 1, I'm going to go to pi over 2. I want you to notice that after pi over 2, it fails the horizontal line test. So after this, notice how the wave goes down and it fails. So I'm going to stop at that point, because if I continue, there's no inverse. So do you see the 2 points I circled at the end here? Those are going to be the ends of your function. Because if you continue past it, it then fails the horizontal line test, and there's no inverse. So I'm only going to go from negative pi over 2 to positive pi over 2, or else it will fail and not have an inverse. So the last one I'm going to inverse is this one down here. The angle is negative pi over 2, and the answer is negative 1. So we're going to inverse it. And have negative 1 and negative pi over 2. Then I'm going to plot that on my graph. Now, when I connect it, it is not going to be a line. See how this is a wave? This is also going to be a wave. But not a wave, but it's going to be a curve. And the curve is going to look just like that. That's the curve of inverse sine. And there's no arrows at the end. So it's just the curve that goes from endpoint to endpoint. You notice I didn't draw a line through here, but it kind of looks like a cube function. In other words, it frowns and then it smiles. This is called the point of inflection. And this is what inverse looks like. Now, most importantly, I'm going to remind you what quadrants we're in. If I go from 0 to pi over 2, that's quadrant number 1. If I go negative here, 0 to negative pi over 2, and I go clockwise, this is now in quadrant number 4. So, when we do our work today, to know what quadrant it's in is going to be important. So, we're in quadrant 1 and quadrant 4 only for inverse sine. All right, let's try the next one. And then I promise you there's no more graphing after this page. It's knowing your unit circle. So, cosine. Cosine starts at the maximum. Then it goes to the middle. Then it goes to the bottom. And if we had it on a graph, it would go back to the middle and then back to the top. Now, again, I want you to notice that we have 3 points that we are going to inverse. So, 1 point at a time here. So the first one is, at 0, the answer is 1. So if I inverse it, then on my inverse graph, it's 1, 0. The next one I'm going to inverse. At pi over 2, the answer is 0. So I'm going to inverse that. So it's 0 and pi over 2. And then the last one I'm going to inverse here is at pi and negative 1. And then inverse that. And again, we're going to draw this with a curve, where that middle point becomes a point of inflection, where it smiles and then frowns going down. I want you to notice in this situation, we're not in quadrants 1 and 4, but this time we graphed it in quadrants 1 and 2. So we have quadrant 1 and quadrant 2. And we didn't have any negative angles. Again, why did I go from there to there? Because if I go beyond it, it now fails the horizontal line test and there's no inverse. So I had to end there for there to be an inverse. And then I graphed it over on the right. Okay, one more. The reason tangent fails? Yes, I'm listening.
Wouldn't that be quadrant 4 instead of quadrant 2?
Switch for cosine?
Yeah.
So, from 0 to pi over 2 is in quadrant number 1, and then from pi over 2 to pi, if you can picture the unit circle, is in quadrant number 2. If I converted it, this would be 90 degrees, and this would be 180. So from 0 to 90 is 1, and then from 90 to 180 is 2. And if I go beyond it, it's going to fail the horizontal line test and not have an inverse. But good question. And notice for cosine, these are all positive angles. But if I go up here to inverse sine, we have negative and positive angles, both. Tangent. Do you picture the picture of tangent? That it goes, repeats and repeats. Do you notice it fails the horizontal line test if we go across? Yeah. So, inverse, we have to realize a thing that tangent starts with a point of inflection. And at pi over 4, the answer is positive 1. And then at pi over 2 is an asymptote. At negative pi over 4, it's negative 1. Those are the points we curve through. And then we have an asymptote at negative pi over 2. Tangent curves up to the right and then curves down to the left. We are going to inverse this graph. So first, I'm going to understand, do you see these asymptotes? Those are vertical. Do you know what happens when you inverse something vertical? It now becomes horizontal. So no longer is it at x equals negative pi over 2. It's now at y equals negative pi over 2. So can you put a horizontal asymptote over negative pi over 2? And the other one, I might as well put a plus and minus sign here, right? So I can save some space. Plus and minus. That the positive pi over 2 is also a horizontal asymptote. So for the inverse, when you inverse a vertical line, it's now a horizontal line. So the easiest point to inverse, obviously, is 0, 0. So when you inverse it, it stays 0, 0. The next one here, at pi over 4 and 1, inverse it, and it becomes 1 and pi over 4, which is right here. And then the last point here, negative pi over 4 and negative 1. If you inverse it and put it on your graph, you have negative 1 and negative pi over 4. This one actually does have arrows at the end. This goes forever to the right and forever to the left. Notice the others have endpoints, but not this one. And the last thing we're going to think about again is what quadrants we're in. So for tangent, if I look at the graph, what quadrants did I graph? From 0 to 90 is quadrant number 1, and then from 0 to negative 90 is quadrant number 4. And which one does that match with that we already did? Is sine. So tangent and sine, it's the same quadrants. So I promise you we're done with graphing.
Wait, are we not going to do the domain range?
Where is it? Oh, is there domain and range underneath? Silliness. So the domain is given to us.
Because I want to learn.
I thank you, Rosie. I want you to learn. And I want to be a better teacher here. So it goes from negative pi over 2 to positive pi over 2. And the domain are the quadrants. Right? And what quadrants did we write down for the domain? 1 and 4. And the range goes from negative 1 to positive 1, right? The bottom of the wave to the top of the wave. Now, if I have the domain and range of the left, what do I do to the right? Just flip them, right? So now the domain goes from negative 1 to 1, and the range goes from negative pi over 2 to positive pi over 2. So if we know the domain and range of the function, then its inverse, we just inverse the domain and range for the other one. Let's keep going. For cosine, we just said the domain we did was from 0 to pi. That's what we graphed from, 0 to pi. The range, hi Kate, the range is the bottom to the top again, which is negative 1 to positive 1. And then once we have this, then we just inverse them for the inverse. Understanding the domain and range is actually very important to getting the answers right here. So I'm really thankful for Rosie to correct me there. And then the last one, tangent. And then we'll talk about that arc in front. So the domain for tangent is all real numbers. Now from negative pi over 2 to pi over 2, we can actually do parentheses and just say it's negative pi over 2 to positive pi over 2, but use... Now, why did I use parentheses here? So it's not included. Why are they not included? Because they're asymptotes, right, at the end? Well, the range is all real numbers. It goes up forever and down forever. Well, now, notice what happens to my domain. Now it goes forever right and forever left, just like the range did. And now my range has a restriction using parentheses from negative pi over 2 to positive pi over 2. And that shows that the ends are not included. Thank you. Wait, before we change, this is going to be new. Do you know normally what exponent do we use for inverse? Now, there is a confusion sometimes with trigonometry with using that. Because sometimes that little negative 1 can actually be the exponent, negative 1. Not the symbol, negative 1, that's inverse. Yo? So that there's a confusion with symbols, yes? So that little negative 1 could be an exponent, or it could mean symbol for inverse. Confusing. So trigonometry says, don't be confused. We're not going to use little negative 1 anymore. Instead, what we're going to use is the word arc in front of it. So when you see arc sine, what does that mean? Inverse. When you see arc cosine, what does it mean? Inverse. Arc tangent. Inverse. So they're not going to use the little symbol -1. Instead, the word arc is used so that there's not a confusion between the exponent, -1, and the symbol, -1. All right, simple. Turn the page. Now we need to know our unit circle. So before I go any further, turn the page. I'm going to assume something, that you kind of forgot the foundation of remembering the unit circle. Maybe you haven't, but here we go. There are 3 special angles I need to know. So you don't have to write it down. You can just enjoy listening to me and watching the screen. 30 degrees, 45 degrees, and 60 degrees. I know that in radians, that would mean the denominator is 6, the denominator is 4, or the denominator is 3. I know the points on the unit circle that go with them. So that's root 3 over 2 and 1/2. That is root 2 over 2, root 2 over 2. And that's 1/2 and root 3 over 2. And it's been like a couple weeks, right, looking at this. So I know it's easy to forget. I need to know the quadrants. One way to remember the quadrants is to say all students take calculus, which is to understand that everything is positive in quadrant 1, sine and its reciprocal, tangent and its reciprocal, cosine and its reciprocal. That's where they're positive. That means if they're not positive, they have to be negative. It's one or the other. And then the last thing are the rules. X goes with cosine. Y goes with sine. Y divided by x is tangent. The reciprocal of x is secant. The reciprocal of y is cosecant. The x divided by y is cotangent. If I know this, then I can be a trig machine. I don't need my calculator if they are special angles like this. So if it's in radians, how do I know if it's a 30, 45, or 60 reference angle? It's the denominator. If it's in degrees, what 2 angles do I use to subtract? Is 180 or 360. And so that will take me to this page here. And how do you remember this? Is by practicing it. That's why some of you still need to do your unit circle again and do it right. You can do it 100 times. And I'll just keep handing it to you until we do it right. Because that's how important it is. And you get 100% in your grade book by doing this. Okay? And if you miss that day doing the unit circle, then you just, hey, come in on lunch. Here's your unit circle and then do it. All right, we need this. Do you know that? Oh, we'll see. Turn the page. Now turn the page. We need this page to do the next page. Now, number 1, it says, can you find the exact value of these inverse functions? So, when I hear arc sine, that means inverse. I want you to know that what you're given is the point on the unit circle. You're given the rule, and what you have to do is go backwards and tell me the angle that goes with that rule. So when you did the unit circle, you were started with the angle, and then you did all that to get the answer, right, from the point? Here, you're given the answer, and you have to work backwards and tell me what angle goes with that number. Got it? So these answers, what am I going to get? Angles. What answer? Angle that goes with it. So, first I need to know, sine, what rule is it? Which rule goes with sine? Do you have that memorized? The y-coordinate. Next, what is the y-coordinate equal? So, when you think of your points on your unit circle, is that going to be a reference angle when the y-coordinate is 1? This is on an axis, isn't it? So, if you need to draw a circle, where is positive 1? Where is it on my unit circle? Can you picture that? And of course, what goes with 1 is what number? 0. And what's my goal? What's the angle there? That's the answer. 90. And you could also write the answer as pi over 2. And if you're avoiding radians, we need to write it more and more and more until you feel like degrees is uncomfortable. And radians is comfortable. Number 2, here we go. Again, what are we doing? Sine. Sine goes with the what? So the y-coordinate is what answer? Root 3 over 2. If that's Batman, what's Robin in front? 1/2. Then you have to work backwards and think what angle goes with that point. And there it is. Now the good news is you don't have to think in terms of all kinds of quadrants. So if the number inside is positive, it's always in quadrant number 1. Always. If it's negative, and we'll talk about it, then you have to think. But positive, it's always in quadrant number 1. So once you know the reference angle, that is it. It's over. And know what it is in radians. So 60 is the same as pi over 3. All right, number 3. Arc sine -2. So where on the unit circle is the y-coordinate -2? Think, 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 and then go, it does not exist, right? There is not. And why is that? -2, what's my restriction for the domain? From -1 to what? Is that beyond my restriction? So the answer is, it doesn't exist. And if you type that in your calculator, you get an error message. So do we have a y-coordinate of -2 on my unit circle? That's beyond it. It doesn't exist. It's over. Hey, let's try for cosine. Cosine goes with the x-coordinate. So what is the x-coordinate here? -√2 over 2. So if the x-coordinate is -√2 over 2, then if that's Batman, what must Robin be? Good. Now, you might think it could be positive or negative, but if the y-coordinate is negative, it's in the wrong quadrant. This is the correct quadrant. What quadrant are we in? Is quadrant number 2. Now, I'm telling you, when inverse is negative, you just have to think a little more. When it's positive, it's always in quadrant number 1. My goal is the angle. So in radians, it's actually really easy because I know the denominator is what? 4. Do you know in quadrant number 2 what that angle is? And so it's 1 pi over 4, and then in quadrant 2 it's 3 over 4. In degrees, it's 135. You might think that's more uncomfortable to write it in degrees. It's easier to write it in radians. I don't know. I think the more you work with trigonometry, radians is simpler. Number 5, what's the problem? It's beyond my domain restriction. Is there any positive 3 in the x-coordinate? Nothing, right? So there's no angle that goes with it. It's over. Hey, 6, -1, is that okay? Yes. But when I do -1, I need to know it's on an axis, not a reference angle. Can you picture that on your circle? What angle is there on the far left? And in radians? Done. You guys are so good, right? It didn't take long for you to remember. Tangent's the hardest one. For arctangent, you're given √3 over 3. Why is tangent the hardest? Because you have to divide to understand the number. Okay? So, when it's √3 over 3, first of all, the answer is not 45. Why is it not 45 degrees? Because that answer would be 1, right? So you have only how many options? So if you write down both options and then think, I'm dividing, which one gives me the answer √3 over 3? Because 1 over √3, if you rationalize it, is √3 over 3. Like this one matches when I go y over x, yes? And then I rationalize the denominator. This one, √3 over 1, the answer is just what? √3. So, which angle is the first one? And the answer is 30 degrees or pi over 6. Next, -1. Which reference angle gives you the answer 1 or -1? And that's root 2 over 2 and root 2 over 2, right? When I divide it, the answer is 1, but it's negative. That means one number's negative and one number's positive. For this answer, it's not going to be positive pi over 4, but it's going to be negative pi over 4. And what's important to recognize for sine and tangent is that when the number is negative, you just write the angle negative. So instead of 30, it's negative 30. Instead of 45, it's negative 45. Cosine, you have to think about quadrant number 2. All right, last one, number 9, root 3. Which is the reference angle when you go y over x? Gives me root 3. And the answer is 60 or pi over 3. As you practice, you're going to see the same numbers over and over again, and it'll get easier because you've memorized the unit circle. All right, some stories. A ship left Port A and sailed 60 miles due east to Port B. I can do that. So here is A and went directly east to B, and that distance is 60 miles. From B, the ship sailed 120 miles northwest. I'm going to run out of space here, but northwest, and stopped. So northwest means north and then west, this angle. I'm going to redraw it down here so we have some space. A to B, from B, north and west means this is the angle. We don't know what the angle is, but we know it's in this area, and it's 120 miles. It says find the bearing from Port B to the current location of the ship. So, we're going to draw a right triangle. All I want to know is that angle. So to find that angle, I need to understand SOHCAHTOA. And for SOHCAHTOA, look at the angle. This is adjacent over hypotenuse. So that's going to be inverse cosine, or you can write it as arc cosine. And then what are the numbers? 60 over 120. And that's the same as 1/2. Do you know what angle goes with the x-coordinate 1/2? So think through your options. If the x-coordinate's 1/2, then the y must be root 3 over 2. That is a 60-degree angle. So this angle in here is 60. What must the angle be on the other side then, so it adds up to 90? So how do I write the bearing of the ship? And we say the answer is north 60 degrees, or 30 degrees, north 30 degrees west. So you go north and then 30 degrees west, and that's the bearing of the ship. All right, number 11. All right. The angle of elevation from a football on the football field to the crossbar on a goalpost depends on D. That's the distance the football is to the bottom of the goalpost. The distance there. So write theta as a function of D. So if I want to write a function on this, again I need to know SOHCAHTOA. And when I look at this triangle, look at the angle. 10 is the opposite side. D is the adjacent side. And which one of these is opposite and adjacent? Oops, I'm going to write it. It's tangent, correct? Opposite and adjacent. So I'm going to write down arctangent of D. Next, we have an equation. It says use your calculator. Thank you. Use your calculator to find the angle when D is what? 75 feet. Oh, I forgot a number. What number did I forget? It's 10 over D. Not D, but 10 over D. So, and this should be F at D. F at D gives you the angle. So I'm going to write down arctangent. The distance is 75 feet. So 10 over 75. Use your calculator. Recognize, if I want the calculator to be in degrees, do you know how to change it? So like my calculator right now says radians. How do I change this calculator to degrees? I press mode. I go down to radian. And then, oh, I went too far. I go to escape. Thank you. Go to radian. And then go to degree. And then press enter twice. Then I can actually do that. Now, the question is, where is arctangent on my calculator? And the answer is, it's in yellow. So, do you see tangent to the little -1 in yellow or green? Press diamond T. And then do you see inverse? And inside I'm going to go 10 divided by 75. And this answer is in degrees. And it says to the nearest tenth of a degree. So if one number after the decimal, the answer would be 7.6. All right, number 12. Here's our last one for today. And then I'm going to let you do a little homework here in class to practice it before your quiz tomorrow on this. So, 2 cables are secured. Thank you. From the top of a 50-foot pole. So when I look at this diagram, can I label 50 feet on the diagram? The lengths of the cables are C1 and C2. Write theta as a function of C1 and C2. So, if I understand this whole angle here, do you see a right triangle in this whole one right here? I need to understand SOHCAHTOA. Is it inverse sine, inverse cosine, or inverse tangent? So, C1 and C2 are the hypotenuse, yes? And the pole itself is the adjacent side. So if I have adjacent and hypotenuse, then which one do I use? So I'm going to write down arc cosine. Now, for the whole angle, not theta, but the whole angle I'm looking for, I need to understand that I'm going to have to do a subtraction. So, if I use C1, that's the whole right triangle I'm going to use, right? If I use C2, that's the smaller right triangle. And then if I subtract them, I get the angle I'm looking for. So again, adjacent over hypotenuse, adjacent over hypotenuse, and I'm finding the big angle, I'm finding the small angle, and then when I subtract them, what I'm left with is theta. A little bit of algebra with the trigonometry. Next, it says, use your graphing calculator, find the angle between the cables. If the longer cable was 120, so then I would put 50 over 120 minus the smaller cable, which is 65. All right, use your calculator, and now tell me the angle between the two cables. So when you access inverse, it's arc cosine. And the angle between them, and again, if we do it to the nearest tenth, it would be 25.7 degrees. That's the angle right there in between the cables. So that's your introduction to inverse trigonometry and some stories. Now we need to do our homework. Mr. G Math, over and out.